Okay, class, welcome back. Let's hypothetically say we are going to have a pizza party. Fun, right? Well, it wouldn't be too fun if we did not order enough pizzas for the entire class and someone did not get to have some. So it would make sense to have an optimally fun pizza party. We would have to make sure that we ordered enough pizzas so that everybody could have some pizza. One way we can do this is by guessing, but that can lead to either buying way too much or way too little pizza, which is no fun to me because I might end up spending a lot more money than I needed to. So to be exact and optimal for both parties and my checkbook, I might have to use a process called dimensional analysis to determine how many pizzas to buy. In this video, my goal for you is to be able to use conversion factors to solve for dimensional analysis problems. So let's dive into this video. Let's start off with what exactly dimensional analysis is. The technical definition for dimensional analysis is the systematic approach to problem solving that uses conversion factors to move or convert from one substance to another. Since we use conversion factors, it would probably be smart to define them as well. A conversion factor is a ratio between equivalent values having different units. For example, we know 12 inches equals a foot, so a conversion factor ratio would be 12 inches to 1 foot. So we know these conversion factor ratios represent a relationship between different units. How, though, do we write these? Well, let's start off by drawing a horizontal line. Our relationship will have a value on the top and underneath that line. So if our ratio is 12 inches in 1 foot, in chemistry we can write it either as 12 inches over 1 foot or 1 foot over 12 inches. Note, not only do we know the relationships to make the conversion factors, but we also can use derived units to make relationships. So, bringing back our last video, our example of density is grams per milliliter or grams per cubic centimeters. Let's say the density of a substance is 3 grams per milliliter. Then I could represent this by writing 3 grams over 1 milliliter, or flip it if I really need to for dimensional analysis. Finally, our percentages can be used as conversion factors. So if a juice contains 10% sugar, then we can say that it contains 10 grams of sugar per 100 grams of juice. So I can represent that as 10 grams of sugar over 100 grams of juice, or 100 grams of juice over 10 grams of sugar. Okay, now that we know how to write these conversion factors, let's continue with what we got. A conversion factor used in dimensional analysis must be accomplished by two things. It must cancel out one unit, and it must introduce a new unit. While working through a solution, all units except the desired unit must be canceled out. Suppose you want to know how many meters are in 48 kilometers. While the relationship between kilometers and meters is there is 1,000 meters in 1 kilometer. To solve this, I would first put my given over 1. So 48 kilometers over 1. I would then use my conversion factor to cancel out and leave me with my desired unit. So in order for something to be canceled out, it must be on the top of one relationship and the bottom of another relationship. So if I have 48 kilometers over 1, then my options for using conversion factors is either 1 kilometer over 1,000 meters or 1,000 meters over 1 kilometer. In order to get the units kilometers to cancel out, I'm going to have kilometers at the bottom of my conversion relationship. This means my relationship should be 1,000 meters over 1 kilometer. Now that we have done that, we multiply our tops and bottoms, then divide our top by our bottom. So if I multiply 48 times 1,000, that's 48,000 on my top. As far as my bottom goes, 1 times 1 gives me 1. So 48,000 divided by 1 is still 48,000. Now I just add my remaining unit, which is meters. So my answer will be 48,000 meters. Okay, let's work a couple practice problems. Calculate how many milliseconds are in 360 seconds. First, I will put my known over 1, so 360 over 1. Then I'll multiply by my relationship of milliseconds to seconds. There are 1,000 milliseconds in 1 second. So I would either use 1,000 milliseconds over 1 second or 1 second over 1,000 milliseconds. Because I have seconds on top of my given, I will use the relationship of 1,000 milliseconds over 1 second. This would result in my seconds canceling out, leaving me with just my desired milliseconds. Now multiply and divide and get 360,000 milliseconds. Okay, let's do one that's a little bit more involved, but this time with our pizzas from the beginning. Let's say we have 25 people to feed in this class, and each person can have 4 slices of pizza. And each pizza cost $15, contains 12 slices. How much do I need to spend on pizza to feed the entire class? Well, let's start off with our people. We're given 25 people to feed, so let's put that over 1. We know each person can have 4 slices, so let's use the conversion factor of 4 slices over 1 person because we want person or people to cancel out. This would then cross out my people's unit, leaving me with slices. Now, let's use the relationship between slices of pizzas and total pizzas. We know there are 12 slices in 1 full pizza. In order to cancel out slices from our prior relationship, we need to use the relationship of 1 full pizza over 12 slices. Now, my last relationship will determine the cost. We know that the cost is $15 per full pizza. In order to get the pizzas to cancel out, I would have to use the relationship of $15 over 1 pizza. Now, all I have to do is multiply my tops, which gives me 1,500, and multiply my bottoms, which gives me 12. And finally, I divide my tops by my bottoms, so 1,500 divided by 12, which gives me about $125 to feed a class of 25 people pizza. Okay, today we learned some pivotal math that we will be consistently using in my class. So, if you need to review, go back, review. If you need to see where the math goes, go back. It doesn't hurt. In saying that, keep up the good work in the class and see you next time.